Alright, so we need to integrate this. Integrating e to a linear function, you take the reciprocal of the coefficient of the exponent. So 0.05 is 5/100ths. 5/100ths reduces to 1/20th. Its reciprocal then would be 20. Then the e to the linear function stays the same. Minus. The reciprocal of 1/1000th is 1,000. E to the exponent stays the same. And I ran out of room here. At the end of this, there should be the evaluated from 0 to 100. That should be right up here to the right. I apologize for that. So this is going to be equal to, we're going to take 100 and put it in for our x's. And we're going to subtract from that, putting in zeros in for our x's. See if I can squeeze this in here. That says, let me rewrite that. This exponent is 0.001 times 0. 0.001 times 0. Simplifying this. 100 times 0.05 would just be 5. So we get 20 e to the 5th minus 1,000 times e, 1,000th times 100 would be 1/10. Then subtract 20 times e, 0 times 0.05 is 0, minus 1,000 times e to the 0, because 0.01 times 0 is also 0. Please note, I just made a mistake. This subtract, we distribute. Subtracting a subtract is a plus. A little more simplifying, we can do 20e to the 5th, simple as we can get it. 1,000 e to the 0.1, as simple as we can get it. E to the 1st is 1. 20 times 1 is 20. E to the 0 is 1. Over here again, e to the 0 is 1. 1 times 1,000 is 1,000. Throw this in your calculator. You end up with approximately 2,843.09. Number 12 here, we need to integrate this and evaluate it from 2 to 5. So integrating this, we're going to end up with x cubed. You add 1 to the exponent, 2 plus 1 is 3. Multiply by its reciprocal. The reciprocal of 3 is 1/3. 1/3 times 3 is 1. And then minus 2x squared, because if you add 1 to the exponent of 1, you get 2. Reciprocal of 2 is a half. Half times 4 is 2. And then this plus 5 is going to be a plus 5x. Add 1 to the exponent. 0 plus 1 is 1. Reciprocal of 1 is 5. So we get 5 times x. We're evaluating this from 2 to 5. Which means we're going to put 5 into the function. And we're going to subtract from that, putting 2 into the function. Simplifying this, 5 to the 3rd is 5 times 5 times 5, which is 125. 5 squared is 25. 5 times 5 is 25. 2 cubed is 8. 2 squared is 4. 2 times 5 is 10. 125 minus 2 times 25 is 50. Plus 25 minus 8 minus 8 plus 10. 25 plus 25 is 150, minus 50 is 100. 8 minus 8 is 0, 0 plus 10 is 10. 100 minus 10 is 90. Well, the directions were to find the area under the curve from 1 to 2. So to do that, we're going to integrate. To find the area, we're going to integrate from 1 to 2 this function, 6x squared minus 1. We're going to find the antiderivative and then evaluate it from 1 to 2. 6x squared would be 2x cubed. Derivative of 2x cubed would be 6x squared, so that shows that that's correct. And then subtract from that x. That's the antiderivative of 1. We're evaluating this from 1 to 2. So that means we're going to take a 2 and plug it in for our x's. Subtract from that, putting a 1 in for our x's. 2 cubed. 2 times 2 times 2, that's 8. 1 cubed is 1. 2 times 8 is 16. 2 times 1 is 2. 16 minus 2 is 14. 2 minus 1 is 1. 14 minus 1 is 13. This is an area, so we say it's 13 square units. Number 14, the directions find the area under the curve between the given x values. So to find the area, we're going to integrate from 0 to 3 the function 12 times e to the 2x with respect to x. So we're simply going to find the antiderivative of 12e to the 2x. So to do that, the coefficient 12 stays the same. You take the reciprocal of the coefficient of x, reciprocal of 2 is 1/2, and then the e to the 2x doesn't change. We're evaluating this from 0 to 3. 6 times 1/2, of course, is, 12 times 1/2 is 6. So we're going to put 3 into this function and subtract from it, putting a 0 into the function. Two times 3 is 6. 2 times 0 is 0. This gives us an exact answer of 6e to the 6th minus 6. E to the 0 is 1. 1 times 6 is 6. This is an area, so we would say it's square units. It's area because the directions say to find the area. Number 15, we're supposed to find the area under the curve on the given interval. The interval is from 1 to 100. Integrating 1 over x, that's a special rule. It's natural log of the absolute value of x. We're evaluating it from 1 to 100. So we're going to replace the x with 100, subtract from it, replacing the x with a 1. The absolute value of 100 is 100. The absolute value of 1 is 1. Natural log of 1 is simply 0. The reason is, this is the same as saying log base e of 1 equals something, such as k, we'll say. Translating this into not logarithmic form, but exponential form, it would be e to the k equals 1. E to what exponent is 1? That's 0, of course. That's why this is minus 0. And then that gives us natural log of 100. It's area, so it's square units.